First sum is pure DC circuit without any dependent source, only independent source. Second circuit is DC circuit but dependent source. Third one is AC. 1 and 3 solved. Now we will solve dependent source. The dependent source is a current source. It gives a current through 30K. What is current through 30K? I0. The current source gives 5 times I0. That current source gives 5 times I0. Now we have to find by superposition theorem. First, let us find by superposition theorem. Let us consider this 10 milliampere alone. 10 milliampere alone. Then what is the circuit? We have to remove this. That's why it will be short circuited. 5K. 10 milliampere. $30K. I0. Five times I0. So, how many nodes are there? How many nodes are there? How many? Only 2 nodes, because this and this are same potential. Only 2 nodes are there. Only 2 nodes are there. Let us call this as P1. This is another node. This is also V1. This is because they are at the same potential. This is also V1. So this is V reference. V reference. Reference equal to 0. Now we have to find V1. If you find V1, we can find I0 dash. We have to find I0 dash. 5 I0 dash means we are considering the first source. Only 10 milliampere we are finding. So we have to find V1. To find V1, we can write KCL because it is current source. That too ideal current source. We should not use, but anyhow, it's given in the book. Let us solve. Ideal current source given because superposition theorem says linear, bilateral, non-trivial or non-ideal sources acting on a source can be considered independently. That is the theorem. And the total current is, or total voltage is sum of all independent sources. That is the theorem. But here, actually, here it is a ideal source because no resistance is here. After removing here, it is not ideal because of 30K. It is not ideal, we can say. Yes, but this is ideal. Sorry, this 10K is 10 volt is ideal. There is no series resistance. Internal impedance is not that. This is in, let us assume that this 30K is internal resistance of that current source, we can assume. But actually, we are considering it as load. Considering it as a load. But anyhow, it can be considered as its internal impedance. But anyhow, let us find, write KCL. What is current through this? 5 I0 dash. Am I correct or not? Current is entering. What is leaving current? I0 dash. What is current through this? 5 I0 dash minus I0. Therefore, 4 I0 dash. Am I correct or not? 4 I0 dash. Am I correct or not? Totally 5 I0 dash is coming, out of which I0 dash is going through 30K. Therefore, 4 I0 dash is coming through this. It is available in the node. Don't consider as a branch. Available in the node. It can be drawn like this. If you draw, I'll after this I'll draw 4 I0 dash. Out of 4 I naught dash, 10 milliamps going through this. That's why what is the current here? 4 I naught dash minus 10 milliampere. I will draw this circuit in the other way. 5K. This is V1. 10 milliampere. And this is 30K. Here one current source is there. That is 5 I naught dash. Current through this is I naught dash. These both are same. Both are same. What is the total current coming here? 5 I naught dash. Out of which I naught dash is going through this and 10 milliampere is going through this. That's why here 4, the remaining current is 4 I naught dash minus 10. Let us assume that current is in milliampere. Current is in milliampere. Therefore, we can write the KCL at V1. KCL at V1 is, so what you will get, this implies V1 equal to how much? Minus 150. V1, this implies V1 equal to minus 150. Therefore, I naught dash equal to, this implies I naught dash equal to what? Divided by 30K, that is equal to minus 5 milliampere minus 5 milliampere. We got I naught dash. Similarly, we have to find I naught double dash. For that, we have to consider this voltage source. So let us consider that. We consider that 10 volt, 5K, 30K, and a current source of 5 I naught double dash. Through this is I naught. Find again, let us assume V1. This node equation, let us write. Let it be V1, let it be V2, or V naught reference, V reference equal to 0. Find it. What is current through this is, let it be I1, let it be I2, let it be I3. Therefore, I1 is outgoing minus V1 plus 10. Why? It is negative terminal is this side. That's why if you come here, it will be minus 10. So V1 to minus 10, minus of minus 10, that's why plus 10. V1 plus 10 divided by 30K. Why minus? Overall minus? Because outgoing current. Minus 6 V1. What is current through this? V1 divided by 5K. V1 divided by 5K. That is also outgoing current. Plus 5 times I naught double dash equal to 0. Because here the current coming in is I naught double dash. But we know that I naught double dash is V1 plus 10 divided by 30K minus 6 V1 divided by 30K plus 5 multiplied by I double dash is V1 plus 10 divided by 30K. Divided by 30K. Equal to 0. Now solve for V1. Solve for V1. I'll write the equation there. Minus V1 plus 10 divided by 30K. I am writing there. Then minus 6V1 divided by 30K plus minus or plus? Plus 5 times I naught double dash. That is V1 plus 10 divided by 30K equal to 0. 30K is common everywhere. That's why minus V1 plus 10 minus 6V1 plus 5V1 plus 50. This is minus, plus 50 equal to 0. Therefore, 7, 5, so minus 2V1 plus 40 equal to 0, or V1 equal to 20 volt. 20 volt. Now we can find I naught double dash. I naught double dash equal to V1, that is 20 plus 10 divided by, what is the formula? What is the formula? V1 plus 10 divided by 30K. V1 is got 20 plus 10 divided by 30K equal to 1 milliampere. Therefore, I naught equal to I dash plus I naught dash divided by I naught double dash, that is equal to minus 5 milliampere plus 1 milliampere equal to minus 4 milliampere. The current direction is opposite to assumed one. That's why minus 4 milliampere. Superposition theorem solved.